Dear students, we are solving exercise 2.2. Now the question is, find the value of tan inverse twice cos 2 sine inverse 1 upon 2. Now here firstly we will find the value of this sine inverse 1 upon 2. Let x equals to sine inverse 1 upon 2, which implies that sine x is 1 by 2. You know that the value of this uh, sine pi by 6 is 1 by 2, which implies that sine x is sine pi by 6 by considering the principal value, which implies that x equals to pi upon 6. Hence when x is pi upon 6, which implies that sine inverse 1 upon 2 is pi by 6. So put x equals to, when this sine inverse 1 upon 2 equals to pi by 6 in the given problem, it is tan inverse of 2 cos of 2 sine inverse 1 upon 2 equals to, in place of this sine 1 upon 2, put pi by 6 here, pi by 6. Now pi by 6 into 2 is simply pi upon 3. So here cos pi by 3 is 1 upon 2, which implies that 2 into 1 by 2 is tan inverse 1. You know that tan pi by 4 is 1, so put tan pi by 4 in place of 1, which implies that the given problem or the given question becomes tan inverse of tan pi by 4. So tan cancels, which implies that the value of this tan inverse of 2 cos of 2 sine inverse 1 upon 2 is simply pi upon 4. Here this pi upon 4, it is in the range minus pi by minus pi to pi. So this is the principal value of this tan inverse of 2 cos of 2 sine inverse 1 upon 2. Now second one is, find the value of cot of tan inverse of a plus cot inverse of a. You know that by using the property tan inverse of x plus cot inverse is pi by 2, which implies that this cot of tan inverse of a plus cot inverse a is simply cot pi by 2, because this angle for this cot is simply tan inverse a plus cot inverse a, which is pi upon 2, pi upon 2. So this means that its value is simply cot pi by 2. Cot pi by 2 is 0, so its value is 0, which is the principal value also. Now the third one is tan of 1 upon 2 into sine inverse 2x upon 1 plus x square plus cos inverse of 1 minus y square upon 1 plus x square. Here we will find the value of the sine inverse 2x upon 1 plus x square, and we will firstly solve this cos inverse of 1 minus y square upon 1 plus y square. Now here sine inverse 2x upon 1 plus x square, if we put x equals to tan theta, which implies that theta is here tan inverse x. So this means sine inverse of 2x upon 1 plus x square becomes sine inverse of 2 tan theta upon 1 plus tan square theta. Now 2 tan theta upon 1 plus tan square is, that it is simply sine 2 theta. So sine cancels, it is 2 theta, which implies that it is simply twice tan inverse x. So value of the sine inverse 2x upon 1 plus x square is simply 2 tan inverse x. Similarly, in this cos inverse 1 minus y square upon 1 plus y square, if we put y equals to tan theta, when we put y equals to tan theta, theta is here tan inverse x, which implies that this cos inverse of 1 minus y square upon 1 plus y square is simply cos inverse of 1 minus tan square x upon 1 plus tan square, sorry, tan square theta upon 1 plus tan square theta. Now you know that 1 minus tan square theta upon 1 plus tan square is cos 2 theta. Cos cancels, it is actually composition here, it is not the cancellation here. This becomes the identity function, so it is simply 2 theta. Now theta is here tan inverse of y, which implies that cos 2 theta is simply 1 minus tan square theta upon 1 plus, because so tan of 1 upon 2 sine inverse 2x upon 1 plus x square plus cos inverse of 1 minus y square upon 1 plus y square is simply tan of 1 upon 2 tan inverse x plus tan inverse y. Now taking 2 common, it will cancel with this 2. It is simply tan of tan inverse x plus tan inverse y. Using tan inverse a plus tan inverse b, it is simply tan inverse of a plus b upon a minus b, that is x plus y upon 1 minus xy. So here this tan and this tan becomes identity functions. So simply we will get x plus y upon 1 minus x square. So this is the required value and it is the general value because we don't know the exact value of x plus y upon 1 minus x y. So it is simply the general value. Now problem 1, we have to find the value of x if sine of sine inverse 1 upon pi plus cos inverse x is 1. We have to find the value of this x. Here sine of sine inverse 1 upon pi plus cos inverse of x is sine pi by 2. Because the value of sine 90 is 1, that is why we are replacing 1 by this sine pi by 2. So this sine and sine, by composing it with this sine inverse x, we get simply, it will cancel, we get sine inverse of 1 upon pi plus cos inverse x is pi upon 2. Now sine inverse of 1 upon pi plus cos inverse of x is simply, that the sine inverse of x plus cos inverse is pi by 2, which implies that in particular sine inverse of 1 by pi plus cos inverse of 1 by pi is pi by 2, because sine inverse x plus cos inverse x is pi by 2 is true for each and every value of x or every real value. So in particular it is true, or it is true for x equals to 1 upon pi. Here this sine inverse 1 upon 5 and this will cancel, so simply we get a cos inverse of x equals to cos inverse of 1 upon 5, which implies that x equals to 1 upon 5. So x equals to 1 upon 5 is the required value of x when sine of sine inverse 1 upon 5 plus cos inverse x equals to 1. Now we have to find the principal value of sine inverse of sine 2 pi upon 3. That principal value, that value which lies between minus pi and pi, or whose value lies between minus pi and pi. Now here sine inverse of sine, this 2 pi can be written as pi minus pi upon 3, and sine pi minus theta is the sine theta, it is simply sine inverse of sine pi upon 3, that is pi upon 3. Pi upon 3 is simply 60, its value lies between pi by 2 to pi by 2, so it is the principal value or the principal value for this expression. Now tan inverse of tan 3 pi by 4, 3 pi by 4 can be written as pi minus pi by 4, and tan pi minus pi by 4 is simply minus tan pi by 4. Tan of minus tan pi by 4 is simply tan of minus pi by 4, because tan of minus theta is minus tan theta, which is tan cancels, it is minus pi by 4. Minus pi by 4 is the required the principal value for this. Similarly you can prove tan inverse of sine inverse 3 by 5 plus cot inverse 3 by 2. If we put x equals to sine inverse of 3 by 5, sine x is 3 by 5. Similarly from cot here, if we put x equals to this here x equals to sine 3 pi by 5 implies sine equals to 3 by 5. Now by using cos square plus sine square is 1, you can find cos is 4 by 5. Now when the cos, its value sec becomes reciprocal of cos, that is 5 by 4. From sec you can find tan equals to 3 by 4, so which implies that x equals to tan 3 by 4. tan inverse 3 by 4. Here value of x is tan 3 by 4. Here value of x is sin inverse 3 by x, which implies that sin inverse 3 by 5 equals to tan inverse 3 by 4. You know that cot inverse x is tan inverse 1 upon x, which implies that cot inverse 3 by 2 is tan inverse 2 by 3. Tan inverse 2 by 3. So we know tan inverse 2 by 3, we know tan inverse 3 by 4, which implies that cot inverse of tan, in this using here by using tan inverse of a plus tan inverse of b is tan inverse a plus b upon 1 minus ab. So you can find tan its value, that is tan inverse 17 upon 6, that is simply 17 upon 6. So 70 upon 6 is the required value for tan inverse of sin 3 by 5 plus cot inverse 3 by 2. So simply we have to put firstly sin x equals to here sin inverse 3 by 5, and using and then calculating, by calculating each and every trigonometric ratio, you can find the value of this tan inverse of sin 3 by 5 plus cot inverse of 3 by 2. The reason for this is why we find all such trigonometric values, because here the angle is here 3 by 5 and here angle is 3 by 2, so there are different angles. So this was all about this exercise 2.2. From tomorrow inshallah we will discuss another unit, that is continuity and differentiability of a function. So thank you.